Okay, so question one. This should be a nice and easy start. It's how to do stem and leaf diagrams. So when you do questions like this, first thing to note is there's going to be 15 students. So to check at the end, you make sure you add up all the numbers and there is 15 numbers. Okay, so we have a look at this, and we've got things in the teens here, we've got things in the 20s, things in the 30s, and things in the 40s. So the stem is going to look like 1, 2, 3, 4. Now it doesn't matter if you write 1, 2, 3, 4 or 4, 3, 2, 1. And then because it's an ordered stem and leaf diagram, we've got to make sure that we write them in order. Now because this is going to be your exam paper, you can write all over it. So what I'd do is I'd circle the teens first of all. So you've got 19, 18, 17 and 18. And if you write them in order, that's going to be 7, 8, 8, 9. You don't need commas in between them, but you won't get marked down for it. Then you cross those off. Now you're going to have the 20, so it's going to be 20, 25, 21, 29, 20, 23 and 22. And then you write those in order. So 0, 1, 2, oh, I missed out a 0. So 0, 0, 1, 2, 3, 5 and 9. Then we've got the 30s, and we've got 33, 37, 37, so 3, 7, 7. Then we've got 42. And then we've got our data. So what I'm now going to do is I'm going to check that I've got enough piece of data. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there are 15 here, so chances are I've got it correct. The final thing we've got to do is got to put a key in there. And so if I just choose the first number 17, I'd write 1 inside a stem, and then 7, let's say that equals 17. Okay, next question. 225 grams of flour, I need to make 9 cakes. Marion wants to make 20 of these cakes. She has 475 grams of flour. Does Marion have enough flour to make 20 cakes? You must show all your workings. So, if I write down what I know to start off with, 225 grams equals 9 cakes. So the most important piece of information, I want to know how much 1 cake requires. So I do 225 divided by 9. So 225 divided by 9, which turns out to be 25 grams. So we've got 25 grams is 1 cake, and Marion wants to make 20 cakes. So if 1 cake is 25 grams, 20 cakes. Sorry, let's write that a bit neater. 20 cakes would be, so we do 20 lots of 25, which is going to be 500 grams. So if she wants to make 20 cakes, she's going to need 500 grams. Now she only has 475 grams, so we'd say that no, as she only has 475 grams, but she needs 500 grams. And that's 3 marks. So far, that's 3 marks for that one, 3 marks for this one. So we get one more question right, and then we've got ourselves a grade E. So we've got to be really, really careful with this next one here. So this is where Simon went for a bike ride, and we've got our travel graph. So at 3 p.m, Simon stopped for a rest. So 3 p.m. is here. So if we go up to the top here, we can see that he stopped for a rest here. How many minutes did he rest? So he then started again at this one here. So we've got to find out the distance, or the time between this time here and 3 o'clock. So we see that this mark that we've drawn just here is halfway between 3 and 4. So it's going to be 3:30. So therefore we stopped for 30 minutes. Next question: how far was Simon away from home at 5 p.m? So what we do is we find 5 p.m. and then we go all the way up to here, and we can see that he was 20. So if we then read across, he was 20 kilometers away. At 5 p.m, Simon stopped for 30 minutes. So we can see at this point here, when he stopped before, when you stop on a distance time graph, the graph goes flat. So he stops for 30 minutes. So it's going to take him up to 5:30. I'm going to make sure that's accurate. So it'll be easy to see on your graph. And then from then, he then cycled home at a steady speed, which means it's going to be a straight line, and it took him an hour and 30 to get home. So what we do is from here, if it was 5:30 when he set off and it takes him an hour and a half, it's going to be till 7, and he's going all the way home. So the rest of the graph is going to look like that. Okay, so let's get rid of that one. Get rid of that there. So that's what our graph should look like. Question 4. The table shows probability that a spinner will land on 1 or a 3. So the probability that the spinner will land on a 2 is the same as the probability that the spinner will land on a 4. So sometimes this is written as x and x. You don't need to do that. But what we should know in all of these types of questions that all the probabilities here add up to 1. So if we add up these two, that adds up to 0.3, which means that the rest of them have to make it add up to 1 whole 1. So it means that the rest of them must add up to 0.7. So you're going to get 1 mark for seeing 0.7. Now we've got two spaces here. We've got the space for 2 and we've got the space for 4. And we're told that they're both the same. So we're looking for two numbers that add together to make 0.7. So they are going to be 0.35 and 0.35. If you're struggling to split 0.7 into 2, make it 0.70 because it's exactly the same. Okay, so the next part of the question is that we've got to work out, so Shunya is going to spin the spinner 200 times, work out an estimate for the number of times the spinner will land on 3. So we've got 0.1. So 0.1, what we do is we work out what percentage 0.1 is. So if we write it as 2 decimal places, that's 0.10, which is 10%. I know you really shouldn't say 0.10, it's inaccurate, but it's what most people tend to think. So 0.10 or 0.10 is 10%. 0.35 is 35%. 0.2, we could write as 0.20, that is 20%. We've got to find out what it is for 3, so that is 0.1. So 10%. So if she's spinning the spinner 200 times, 10% of that would be 20. So to find 10%, you divide by 10 or move the decimal place over. This question here, John has a flower garden in the shape of a circle. The diameter of the garden is 5 meters. John wants to put fencing around the edge of the garden. The fencing costs £1.80 per meter. So we're going to have some fencing, which if it starts here, it's going to go all the way around the outside here. Almost a perfect circle. So if we're looking around the outside of the circle, that's what we call the circumference. And one thing that we have to remember in exams is circumference equals pi times by the diameter. The other one that we have to remember is area of a circle, which is pi times radius times radius. But for this one, we're looking around the outside. So circumference equals pi times diameter. Now, pi is the same as 3.14, and we can use 3.14, or we can use a pi button on your calculator. For this example, I'm going to be using the pi button on the calculator. So what I'm going to do, if I want to work out the length all the way around the outside of my flower garden, I'm going to do pi times by the diameter, which in this case is 5, because 5 is all the way across. The diameter is all the way across. If I wanted to know half the way across, which would be 2.5, that's what we call the radius. So the radius is from the outside to the middle, the diameter is all the way across. So on my calculator, I type in pi times 5, and I get the answer 15.70796327. And so that is to the nearest millionth of a meter how far around the flower garden my edge is. Now what I want to do is I want to buy this much distance in fencing. So I want 15.7 meters of fencing. I know that the fencing costs £1.80 per meter. So what I'm going to do is I'm going to keep this whole answer in my calculator. I'm going to multiply it by £1.80. And then if I do that, I end up getting 28.2743388. Of course, this is no use to us because nothing costs £28 and 2.274338. So we round to the nearest pound and pence. So what we're going to do is round to £28 and 27, and then we're going to see if the next digit rounds it up, which in this case it doesn't. So the answer is £28 and 27 pence. Now some people did this slightly differently, and when they got to this stage here, they assumed that you could only buy the fencing per metre, which is absolutely fine. So they said that 15.7 gets rounded up to 16 metres, then they did 16 lots of £1.80, and that's got them £28 and 80 pence, and you still get the mark for that. Okay, moving on to question 6. Mr. Watkins needs to buy some oil for his central heating. He can fit up to 1,500 litres of oil in his oil tank, and there are already 850 litres of oil in the tank, and he wants to fill it up. So what I'll do, if there's too many words here, I'd actually draw a diagram. And this is Mr. Watkins' oil tank, which can hold up to 1,500 litres, and he's already got, here, 850 litres. So in order to fill it up, he's going to need to fill it up all the way to the top. And if it's 1,500 all the way up to the top, and he's only got 850, then the first thing I'm going to do is see how much extra we need. So 1,500 take away 850, and that would equal 650 litres. And that's where my first mark is. It's worth 5 marks down here, and that's what the first mark is going to be for. Now we're told that the price of oil is 67.2 pence per litre, and I want 650 litres. So I'm going to do 650 times 67.2. So 650 times 67.2 gives me 43,680. Now, because what we multiplied by was 67.2, that's 67.2 pence. So this thing here is 43,680 pence. Now, of course, no one asked for 43,000 pence. It's all in pounds. So what we do is we need to put in 2 decimal places, and if we do that, that's going to be £436 and 80 pence. So that's going to be the cost of it. However, we are now told that Mr. Watkins gets 5% off this price. So you've got a calculator. There's 2 ways to do this. You can either do it the non-calculator way and find 10% by dividing by 10, which would be £43 and 68, and halve that to get £21 and 84 pence. And then it says that he gets a reduction, so he gets to take this off this amount. So we could do £436.80, take away the 21.84, or we can quickly find out what 5% is by doing 5% as 0.05, and then you multiply it by 436.80, and either way you still get £21 and 84 pence. What you then need to do is you need to take off your discount from your amount. So the final step is £436 and 80 pence, take away £21 and 84. So that gives us £1 and 84 pence, £414 and 96 pence. Now, if we've done all of this up to and including this question, so question 6 out of 20, what is it? We've got 25 questions. Then we get ourselves a solid grade D. So that's just for doing 6 questions. Of course, we want to get more than a D, and so we're going to continue with the video. But up until this point, you want to try and make sure you get as many of these marks as possible. Okay, question 7 was quite a reasonable question, I thought. Peter goes for a walk. He walks 15 miles in 6 hours. Now, if you go to the science department, they often teach you about distance, speed, and time. No, sorry, my mistake. Speed, distance, time. I don't like that. so I've never used it because I think it gets confusing when we talk about different units. It does work in this case, and we are going to sort of use the same math behind it. But I think this way can get confusing when you talk about different types of units. So if you've got to change between hours and minutes, I think there's a far easier way to do it. So I'd write down all the information that I know. So in 6 hours, Peter walks for 15 miles. But we want to know what his average speed is in miles per hour. Now what miles per hour means, if you split it down to the 3 words, is how many miles you go in 1 hour. So that's exactly what I'm going to do. I'm going to find out how far I go in 1 hour. So to get from 6 hours to 1 hour, I need to find a sixth, or divide by 6. So if I do 15 divided by 6, I get 2.5. So that means every hour I go 2.5 miles. So I'm going 2.5 miles per hour. Okay, then it gives you the 5 miles equals 8 kilometers information that we need for our next question. And Sunita says that Peter walked for more than 20 kilometers. So we can see from the first question that he's walked for 15 miles. So 5 miles equals 8 kilometers. We want to know how far 15 miles is. So as you can see, all we do is we treble it. So if we treble that, we get 24 kilometers. And so we go back to the question, is Sunita right? Yes. Yes, as 24 kilometers is bigger, I'm going to use the math symbol, is bigger than 20 kilometers. You got away with just using the word yes and then showing these workings, but I'd always try and put in the little bit extra workings just in case. Okay, question 8 is trial and improvement. Now as soon as we see the word trial and improvement, the first thing I always do, and my class will know this, is to do a table. And I write my value of x, if the letter is x that we're looking at. I write down the equation x cubed minus 3x, and I write down bs, which obviously refers to big or small. Now, we're told that the solution is in between 2 and 3. So the first thing I'm going to try is what's in the middle, so 2.5. So in my calculator, I'm going to write 2.5 cubed, take away 3 lots of 2.5. Now, people that do drop marks on this tend to get the 2.5 cubed bit right, but then they just take away 3. Remember, it's not take away 3, it's take away 3x, which means 3 lots of your number that you're trying. So if you do 2.5 cubed, take away 2.5 times by 3, you get 8.125. Now we want it to equal 15, so this is far too small. So the next thing we're going to do is we're going to try something bigger. So 2.8. So we do 2.8 cubed, take away 3 lots of 2.8, and by doing that we get 13.552, which again is too small. So we're going to try 2.9. So we do 2.9 cubed in the calculator, take away 3 lots of 2.9, and we get 15.689. Now, if I talk to you about the marks, the first mark we get is for trying anything that's in between 2 and 3 and making sure that we get an answer from it. So that gets us 1 mark. The next thing we get a mark for is getting it trapped between these two here. So we've got it trapped between 2.8 and 2.9, and that gives us our second mark out of 4. So the next thing we do is if we know that 2.8 is too small and 2.9 is too big, then even though it says to 1 decimal place, we've got to do it to 2 decimal places once. So we try what's halfway between 2.9 and 2.8, so 2.85. So we do 2.85 cubed, take away 3 lots of 2.85, and we get 14.599, which is too small. So if the one that we check in between, this is our checker here, so if the one that we use as our checker is too small, we go for the bigger one. If this one's too big, we go for the smaller one. But 2.85 is too small, so the correct answer is 2.9, and that's what we write down there. So it's going to be our 4th mark, but the mark that most people forget is this one here. So first, I'm going to go through those marks again. First mark is for trying anything between 2 and 3. Second mark is for trapping it between 2.8 and 2.9. The third mark is once you've got it trapped between these two here, is you go and you check what's halfway between them. So you check 2.85. Then dependent on the outcome of this one, if it's too small you go for the big one, if it's too big you go for the smaller one. You go back, and because it's too small we went for the bigger out of the two, 2.9 and 2.8, so 2.9. Question 9. Work out the volume of the prism. Now, volume questions come in all different shapes and sizes, no pun intended, but the way you calculate the volume of the prism is pretty much the same every single time. And the first thing we've got to do is we've got to work out the area of the cross section or the flat shape. So ours looks a little bit like this. And what we're going to do is we're going to split it into two shapes. So now we've got this rectangle here, and we've got this rectangle here. And I'm going to work out the area of both and then add them together. So the first one is 5 times 7, so that's going to be 35 centimeters squared for this bit. Now this one here, even though I've drawn over there, now this one here isn't actually 4 times 11. This side here is certainly 4, but this side here isn't 11. 11 refers to all the way across, and this is where people drop the marks. Now we know from this point here over to this point here is 5 centimeters. So if this bit here is 5 centimeters and it's 11 all the way across, this bit here must be 6 centimeters. So now we've got 4 centimeters here, and we've got the width, which is 6 centimeters. So if you multiply those two together, you get 24 centimeters squared. So if we add those two together, the area of the whole cross section is going to be 59 centimeters squared. So once you've got the area of the whole cross section, it's the cross section multiplied by how far back it goes. So we worked out the area of the whole shape here, which is 59 centimeters squared. So 59, then we're going to times by how far back it goes, which in this case is 20, and you get 1,180 centimeter cubed. Be careful on this question because often they'll write state your units, and this is quite sneaky. And then what will happen is that they won't have this bit down here. And so if you just wrote 1,180, you'd get 3 marks, but you'd lose the 4th mark. State your units means that you need to make sure that you put it either meter squared, centimeter cubed, millimeters, whatever it is units that you're looking at. If it's volume, the units are always going to be cubed. If it's area, the units are always going to be squared. And if it's just a length, it's just going to be just the units, so centimeters or millimeters or miles, or whatever it turns out to be. The next question, now again, this question comes up so often, so this is a really, really good way of making sure that you get the right answer. We've got to fully describe fully the single transformation. I'm going to underline single there, because we can't say it's been moved over and then it's been rotated, or it's been enlarged and then it's been moved, or reflected and then moved. Single transformation means that it's only one thing has happened to it. Now, transformation, there are 4 different types. There's a translation, and that's when something's just picked up and moved. There's rotation, when it's been spun around, but you have to use these words. There's a reflection, and that's when something's been reflected in a mirror line. And then there's also an enlargement. Now with enlargement, even though it sounds like it means it's getting bigger, enlargement can also mean getting smaller. So it means either getting smaller or bigger, just changing the actual size of it. Now out of these 4 here, we just to get from P to Q, we've picked up and moved it. So we're going to get 1 mark for using the word translation. And the second mark is for describing how far it's been translated. And what we do is we just pick on any of the coordinates. So the top right hand corner to the top right hand corner, we go 1, 2, 3, 4, 5, 6 across, and then 1 down. So we write that as a vector, and the way we write 6 to the right and then 1 down is 6 and then minus 1. So you write it a little bit like coordinates, except 1 coordinate is on the top, 1 coordinate is on the bottom. Now when you do this, you can choose any coordinate. So for instance, this one here to the bottom here, again we go 1, 2, 3, 4, 5, 6 across. and then 1 down. So it doesn't matter which point you choose, as long as you choose one of the points. If you wrote 6 minus 1 and make it a fraction, then you lose the mark. Please make sure, and a lot of people do this, so that is wrong. Make sure you don't do that. 6 minus 1 is correct. 6 minus 1 where you've got a line is incorrect. If you were to go to the left and then up, so for instance, if our shape looks like, let's see, that, then we go to the left by 2, then up by 3. So because we go to the left, that vector would be minus 2, and then 3 up. So the minus means that you go the opposite direction. Usually you go to the right along the corridor and up the stairs. However, if you have to change those at all, then, so for instance, if you was going this way, that would be a minus number. If you were going to go down, that would also be a minus number. Okay, so those are the first 10 questions, and that's where this video is going to end. Once you've done that, again, feel free to pause this video, to rewind this video at any time. When you come to do your revision, you should watch these videos over and over again. I know I keep saying it in class, and I'm going to keep saying it on here. These videos are absolutely vital to you doing your exams because the questions don't change from one exam to the other. And if you've watched this video and watched all the other videos all the way through to the end, and you've taken notes and you're fully engaging with it and you understand a lot of what we're talking about, you will do well on your exam. That's how easy it is. Just to watch these videos, really absorb everything, take notes, make sure you understand, rewind it if you don't understand, ask more questions, come in and speak to either myself or Mr. O'Rourke or your maths teachers, and we'll go through anything with you. It is important that you do the revision, and this is a perfect way to do that. Okay, so once you've done these, if you want to move on to the next video, that would be perfect.